In this video, we're going to look at Venn diagram shading. In the last section, we looked at set operations given sets listed by roster method with the elements in it, and then we performed all the set operations. In this case, we want to show the portions of the Venn diagram shaded by a given expression. So for example, I might ask you to find A intersect B complement, and I would want to shade which parts of the Venn diagram this refers to. Now there's lots of different ways to do shading. We could shade the A with one color or one direction and shade B complement with another direction, and then because it's an intersection, we want where do these two regions overlap, and we could look for where they're cross-hatched. The problem is once you get into three sets or you start getting longer expressions, shading in different directions and colors and putting them together gets very complicated. In a small situation like this, you might be able to visualize the answer. You might say, well, let me take all of A and just kind of use your finger to represent A, or use a cursor like this, and we want to intersect that with B complement. Well, B complement is everything outside. So if I take everything outside of B and put it and overlap it with A, I can see that this moon here, the part that's in A and not in B, is going to be my final answer. So for a simple expression like this, maybe you could just kind of try to interpret this and just see the answer. That's great if you can do it, but it can get complicated, and you can't get any partial credit when you do something like that. So there's another method we can use where we essentially recognize every region, 1, 2, 3, 4 regions here, and 1, 2, 3, 4, 5, 6, 7, 8 regions here, and we'll label them. Now, traditionally, we use Roman numerals. Okay, 1, 2, 3. When we get to 4, we use an IV. The V stands for 5, so IV means 1 before 5. And you can really use whatever notation you want here. There are some applications of Venn diagrams where we use regular numbers to represent how many elements are in those regions. So traditionally, we will use Roman numerals. That's how I'm going to continue to do it. And then what you can do is basically turn this Venn diagram problem into a set operation problem like we did in the previous section. So when we look at the set A over here, A is really just the set of regions 1 and 2. So we'll represent A as 1 and 2. And we want to intersect that with B complement. Well, since B includes 2 and 3, B complement includes 1 and 4. Now, for a small example like this, I think it's fine to see that, but your other option is to always write out B first and then write out B complement. Okay? And now, since you're doing an intersection, you can hopefully see that the answer here is, we'll use the equal sign just to keep this consistent, is just the region 1. And then what you would do is you would shade this area here as your answer. Okay? So this is going to be an effective way to do Venn diagram shading for large problems. Now, when we label over here, we traditionally go across the top 1, 2, 3, and then we go 4, 5, 6, and then we go across the bottom 7 and 8, usually represents this outside area. Now the way you label them does not matter, but it will certainly change the values you have each step along the way. So if you decided to call the outside 1 and this 2, 3, and 4, you would have had different answers here. You would have had the region referred to as 2 instead of 1, but ultimately you would still have the same shaded region. Okay? So the first thing you have to do is be able to draw these Venn diagrams. With 3 sets, you have to have the circles overlapping, sort of like the Olympic rings here, at least 3 of them, so that you have every possible overlap. This region 6 over here is in B and in C, but it's outside of A, and you've got to allow all of those possibilities. Okay, so now let's look at some more examples. We're going to start with a couple here that are 2-set Venn diagrams, and I'm going to start, as always, once I recognize that it's only 2 sets, I'm going to draw my Venn diagram with 2 sets. Okay, so here it is, labeled a little bit more cleanly. And what I'm going to do now is I'm going to try to calculate or evaluate A complement union B. Okay, now if it helps to write that A is 1 and 2, it may make it easier to see that A complement is 3 and 4. Okay? Then you want to put that together with B, which is 2 and 3. Right, and that's going to give us 2, 3, and 4. Okay? So ultimately, when we do our shading, we want to shade 2, 3, and we want to also include all of 4. Basically, in this case, everything except for 1. Okay? Again, you could label these regions anything you want, but once you label them, your answers will maybe change along the way here, but the final shaded region will still be the same. Okay, I just turned these letters back to black here so they would stand out a little bit better. Okay? Okay, so now we're going to do another one. And in this one, we want to do A minus B, then take the complement. Okay? So again, I pull up my drawing. You may have to practice this the first few times. First thing we have to do is here what's in the parentheses is A minus B. Well, remember that A minus B says to start with A and then remove anything that's in B. So A minus B is going to be just the region 1, and then we're going to take the complement. Okay, so the complement of 1 will be 2, 3, and 4. Okay, which, I'll just use red to shade here, will be everything here okay. And if you notice something, these two gave us the same exact shaded regions. Okay, now as far as we're concerned this semester, that's fine, it's just a coincidence, it's nothing we need to really be concerned about. But if you do study sets in any more detail and get a little bit more theoretical about it, there are set properties. And if you remember we did logical equivalences, we said that two expressions were logically equivalent when they gave you the same truth tables. In this case, these two expressions must be somehow equal because anything in one is going to be in the other. They give us the same region on a Venn diagram. Okay? For us, it's just sort of informational. It's nice to see situations where you can describe the same regions using different expressions, but for us, that's all we need to worry about. Just do it. Okay, so now we're going to step it up a little bit to the 3 set Venn diagrams and start off here, no complements, just to try to keep things simple. Again, once you have 3 sets, you have to worry about order of operations, so you probably want to start with what's in the parentheses first. So we're going to take A, which is 1, 2, 4, and 5, and union that together with B intersects C. Well, B intersects C is this portion right here. Right? That's where B and C overlap. Now you could write all of B out and all of C out and then find the intersection that way, but we can sort of do a little bit of work visually here. That gives us V, 5, and 6. Now, if writing the Roman numerals is really difficult for you or it's causing problems, then just find a different way to label them. Either use regular numbers or use lowercase letters or something. Don't let that be an obstacle for you getting this right. Okay? So now we're going to take A together with B intersects C. And you can sometimes talk these through and visualize them. If you can see that this is B intersects C and you can see that this is all of A and this union is going to put them together, you might be able to tell that this is going to be the answer here. But if not, right, that's what we have this method here to do. So now we take the 1, the 2, the 4, the 5, and throw in the 6 we didn't already have, and then we go to shade. Okay, so I'll use black to shade here. Okay. I'm covering up some of the Roman numerals, which is fine. Right. but I've got the area shaded here. Okay? Now we're going to do this one more time. This complicated expression may take a little bit more work, but it's the same basic principle. Okay, so now we have our diagram, and we're going to start with A complement. Now the one thing you've got to be careful about when you have three sets is A complement should be everything outside of A, right? And that includes the outer region. There are four things in A, so there must be four things outside of A. So we're going to start with A complement, which will be 3, 6, 7, and 8, right? Together with B, which is 2, 3, 5, and 6, right? And then we're going to have to intersect that with C complement, right, which is everything outside of C. 1, 2, 3, and 8 minus B, which is 2, 3, 5, and 6. Just ran a little bit out of room here. Okay, so we're going to have to give ourselves a little bit more room to do this. Here we're going to do a union. So I'm going to finish this parentheses first. I'm going to throw these all together into one set. I start with the 2, then I have the 3, then I get a 5, a 6, a 7, and an 8. Okay? And again, this here, this first part underlined in blue, represented A complement together with B. So I'm taking all of B plus everything outside of A. So I got the 2, 3, 5, 6, 7, 8, 2, 3, 5, 6, 7, 8. Okay. Now I need to intersect that with this set difference over here. Okay, and remember, the set difference, you always start with the first set and you remove anything that also shows up in the next set, but you don't throw anything else into it. So this gets intersected with 1, 8. Okay. And then the intersection, the only thing that shows up in both of these sets is 8. Okay? So the final answer here for this shaded region is just everything outside of all three circles. And that, I think, is going to be the easiest way to do these. You certainly can do it another way if you've learned, but I think with all the different shadings and cross-hatchings and different colors, it gets confusing. Again, if the Roman numerals are a problem, just find another label to use for them. Work out the set operations as if they were just elements of a set, except now the elements refer to the regions of the Venn diagram. Okay, now you need to practice a few of these to really solidify this skill before you move on.